Alrighty, sixth graders. So today we're going to be going over a video. As you can see up here, it says the mini lesson is this video today. It will be on ratios, unit rates, and unit cost. So I put the blue here today as ratios because you guys already know what ratios are. We've been talking about part to whole, and whole to part ratios. This week we're going to be furthering our understanding on ratios and going into unit rates and unit costs. So when you look at these today, the one thing I want you guys to look at is the word unit, okay? And we'll talk about what that means later in this video. We're going to go ahead and get started, so if you could take your notes out and follow along on your notes, we'll be ready to go. So today, I want you guys to go ahead and solve these problems. Okay, it says question number 1 for your bell ringer. They want you to write the ratio of the number of Milky Ways in this picture to the number of Snickers in this picture in 3 different ways. So remember last week we talked about how we can write ratios with colons, the word to, or as fractions. So think about that. When you're done with that, they want you to write a ratio of the number of 3 Musketeers to the total number of candy bars in this picture. The third question for your bell ringer today is what type of ratio is question 1? Is it a part to whole, or whole to part? And what type of question is question 2? Or what type of ratio is question 2? Is it part to whole, or whole to part? Okay. Question 4, we also learned in the previous target about equivalent ratios. So we want you to figure out what is an equivalent ratio to the answers that you had in question 2. So go ahead and answer those. The questions here on Edpuzzle will allow you to type in your answers, and we will go ahead and move forward. All right, so today, like I mentioned before, we're going to be talking about unit rates. Okay, a unit rate, when you look at the word unit, I always think of the word uni for a unicycle, okay, or a unicorn. But what do we know about a unicycle or a unicorn? They have one wheel, right, or one horn. So you're always trying to figure out how much is in one. So go ahead and put 1 in your blank space on your notes, okay? A unit rate is also a ratio. It compares, okay, which we talked about, ratios compare. It's also expressed as a quantity of 1. That's basically saying the same things, boys and girls. It's saying you're trying to figure out how much is in 1. Okay, so down here I have a few examples. It says there are 120 crackers and 6 servings. How many crackers are in 1 serving? All right, a Cubs player hits 6 home runs in 3 games. At this rate, how many home runs will he hit in 10 games? So we're going to talk about how we can find the answer to these problems as we go through. Okay, the next thing I want you to fill in your notes is the idea of the item over the amount, okay? So let's go ahead and let's look down here at question 2. I'm going to go ahead and get my pen. All right, and they're saying a Cubs player hits 6 home runs in 3 games. So I know I'm going to say home runs per game. All right, so my item, I have 6 home runs. In how many games? Well, in 3 games. So just like when we were talking about how I can find equivalent ratios, there are multiple ways you can find an equivalent ratio. Okay, but I know one we're all familiar with as a class is setting that equal, okay, to the idea of 1. I want you guys to think about when else we have used equivalent ratios before. And many of you are going to say, Ms. Swiderski, isn't this just a fraction where we're finding equivalent fractions? Some students can look at that as well and say, okay, well, to get from 3 to 1, what do I need to do? Right, I divide by 3, and if I divide by 3 on the bottom, what should I do on the top? Well, 6 divided by 3 should give me 2. So, Ms. Swiderski, what does this mean? I have 1 on the bottom. You said I needed to find 1, right? Yeah, so if I have on the top here, we had home runs was 6, games was 3. That means in 1 game, at this rate, the Cubs player will hit 2 home runs, okay? So if he hits 2 home runs in 1 game, how many home runs at this rate would he get in 10 games? Well, if we know 1 was 2, all I really need to do to get from 1 to 10 would be to multiply by 10. Well, what is 2 times 10, boys and girls? 2 times 10 should give me 20, or a unit rate of 20. Go ahead and try this one here. It says there are 120 crackers and 6 servings. How many crackers are in 1 serving? My first question for you is, how would you set this up as a ratio? And then how can I figure out how much is in one serving? Go ahead and solve that. All right, we're going to go on to the next slide. Another question for you, Starbucks. Okay, so Ms. Widerski, when are we going to use this in our real world? When do we use this on a daily basis? Okay, again, you're going to see our target down here. I can use ratios to understand relationships between unit rates, which we learned about, and unit costs, which we will be moving into. Okay, so up here it says, let's try together. An employee at Starbucks can make coffee drinks at a rate of 4 drinks per minute. So we've talked about the word per and how that's comparing two different things. So if I have 4 drinks, go ahead and copy this down for me, per minute, okay, 4 is on top, 1 minute is on bottom. Remember, 4 drinks, go up here. So I'm going to write drinks. Sorry, my mouse is being a little picky today. Per 1 minute. Okay, now how can I figure out at this rate? So if this coffee guy, coffee maker at Starbucks, a barista is what they call them, at this rate, if he's making 4 drinks in 1 minute, how can we figure out how much he would make in 30 minutes? Okay, well, if I know he makes 4 drinks in 1 minute, I can set that equal to, okay, question mark, how many drinks, we don't know, okay, in 30 minutes. Okay, how would I get from 1 to 30? Well, you can multiply by 30, right? So if I times by 30 on the bottom, what do we have to do on the top? We should have to times by 30. So 4 times 30, well, I should get 30 times 4, right? A great math student will make sure that they check their work. 0 times 4 is 0. 3 times 4 is 120. Ms. Widerski, what does that mean? Well, if drinks is on top, and now we have 120 up here on the top, okay, that means they can make 120 coffee drinks, which is a lot of coffee, in 30 minutes. Okay, so, Ms. Widerski, when do I need to know this? This is important if you're hiring a great employee, right? Or if you're saying, okay, I need to get 120 coffee drinks for all my friends on my 6th grade floor. How long is it going to take this guy to make my drinks? So, coffee, drinks per minute is another great example of a unit rate. All right, the next one we're going to talk about, I took this straight off of Digits as well. It says connecting two graphs and tables. A 5-minute shower uses approximately 12 gallons of water. Okay, it says each minute the shower is running, the rate of water used is the same. Use the rate to complete the table. So when you talk about rates with this, would you say water or gallons per minute or a minute per gallon? Okay, I usually say gallons per minute. That would be our rate for this. So if you have 12 gallons, okay, and 5, we need to try to figure out, that's 5 minutes, how much would be used in 1 minute. So how would I get from 5 to 1? Well, many of you would say, okay, Ms. Widerski, I'm getting smaller. Okay, so I know I'm going to divide by 5. Well, if I divide by 5 on the bottom, I need to divide by 5 on the top. Sorry about that. Okay, and I know that 12 divided by 5, when you do that on your notes, would give you 2.4. What does that mean? Okay, well, we had 12 gallons in 5 minutes. Now we have 1 minute. 1 minute shower uses 2.4 gallons or 2 4/10 gallons of water per minute. So on your notes, I want you guys to fill that in. Well, if we know now that 1 minute uses 2 4/10 gallons of water, okay, how can I figure out how much 2 minutes would be? I've seen a few students do this in different ways, okay, and that's math. We can totally do our own way as long as we get to the same answer and we touch base on how we used our math skills to get us to our answer. I'm okay with that. Many students say, okay, Ms. Widerski, well, I know 2.4 plus 2.4 will give me 4.8. Okay, well, Ms. Widerski, I just added 2.4 plus 2.4 because I'm doubling that. That's great. Is there another way we can get our answer for that? Okay, I see it and I say, okay, well, 2.4 or 2 4/10 times 2 would also give me 4.8. Okay, so then you might say, all right, Ms. Widerski, well, to get 3, I'm going to go ahead and do 2.4 times 3. All right, well, what is 4 times 3? Be 12, carry your 1. 3 times 2 is 6, plus 1 is 7. Okay, how many times do I need to cha-cha slide with my decimal? And the answer should be just once. So I will get 7.2, or 7 2/10. Okay, 5 was our given. All right, now we need to do 12. So how can we figure out how much water is used if someone takes a 12-minute shower? The answer should be 12 times 2.4. Okay, so if we do 12 times 2.4, all right, I know 4 times 2 will give me 8. 4 times 1 is 4. 0 is a placeholder. Okay, 2 times 2 is 4. 2 times 1 is 2. Okay, let's touch base here as we add these together. 8 plus 0 is 8. 4 plus 4 is 8. 2 plus nothing is 2. I need to cha-cha slide just once. So I should get 28 8/10. Ooh, sorry, my screen is freaking out today. All right, and I want you to go ahead and figure out how much water would be used in 16 minutes. Go ahead and do that now, please. All right, I know 16 multiplied by 2 4/10 would give me 38 4/10. Let's go ahead and copy this down. All right, now, Ms. Widerski, I got 12 or 16 another way. That is totally possible based on how you did your math. But realistically, if you know how much is in 1, all right, so we said in 1 minute, they use 2 4/10 gallons of water. You can multiply however long your shower is. Maybe you're like Ms. Widerski and you take long showers. You can multiply it by however many minutes you were in the shower, okay, multiplied by 2.4, and you can figure out how much water is being used in that shower. Okay, so Ms. Widerski, where might a student get this wrong? Okay, I've seen a lot of students get 2 4/10 right here, okay, and then I've seen some students get 2 4/10 plus 2 4/10, which would be 4 8/10 here, okay. I've seen some students, okay, at this point say, okay, well, Ms. Widerski, if I multiply 2.4 times 2, I get 4.8. I've seen some students go ahead and say, okay, well, I know then that to get 3, I need to do 4 8/10 times 3, okay, 8 times 3, 24, carry your 2, you get 12 plus 2 is 14, okay, cha-cha slide once. What do you think this student is doing wrong right here? So they got 14 4/10 here, okay, and then they say, okay, Ms. Widerski, well, 14 4/10 multiplied by 12, okay, and they'll go through, they'll show all their work. All right, so as you see this, they're going over, they're saying, okay, well, I did 14 4/10 multiplied by 12 because it's a 12-minute shower. What do you think the student's doing here? Are they using the unit rate appropriately? Why or why not? Go ahead and put that in your response, and we'll touch base on that tomorrow. All right, so now we're going on to a multiple representations question. I want you guys to fill this one out in your notes and answer it to the best of your ability. Tomorrow we're going to touch base on how do I set this up and why. Now remember, everyone may get the same answer, but it doesn't mean we all need to take the same avenues to get our answer. It says the Pantagraph, which is the local newspaper, is looking for a new employee to type articles that will be published in the newspaper. The company wants someone who can type at least 45 words per minute. So words is on top, minute is on bottom, okay? Or minutes, depending on how many minutes you need. Joe can type a constant rate of 704 words in 16 minutes. Does Joe type at a fast enough rate for this job? Explain your work. So I'll give you a couple givens, and then I want you guys to get creative in how you solve your answer, and we'll solve it tomorrow as a class. All right, so here's our givens. We know that they can type, or they're looking for somebody who can type 45 words per minute, so 45 words in 1 minute. Okay, notice how I put words on top, minutes on bottom. So now they want you to look at this 704 words in 16 minutes, okay, and figure out if they type, our friend Joe can type at a rate that is faster than 45 words per minute. If they are slower than 45 words per minute, they do not want to hire that person. They want to make sure it's 45 words per minute or faster. Go ahead and get creative. You can use picture diagrams, words, show your work, and we'll go over this tomorrow.